This problem looks a little overwhelming because the first paragraph of the problem is really just a chemistry description of the equation. We have nitrogen monoxide, it's a pollutant released by automobile engines, it's oxidized by oxygen, so there's the oxidation of oxygen to give a reddish-brown nitrogen dioxide. Remember, one nitrogen, two oxygens, and this is the balanced equation. Now, this whole beginning of the problem really not relevant to what you need to accomplish in this problem. It's just a nice little background story, so don't be overwhelmed by this problem. However, this problem in this gas loss unit is a little bit unusual because a balanced chemical equation is being presented to you, which can be a little distracting to the normal problem. So with this problem, we're dealing with how many milliliters of oxygen measured at 293 K and 755 millimeters mercury are needed to react with 180 milliliters of nitrogen monoxide, NO, measured at 318 K and 720 mmHg. It looks like there's a lot going on in here, so to help us organize our thoughts, let's set up this problem. Now, there's going to be one slight difference in this problem than the other problems I've shown you using this PVTN chart. Now, in this problem, we're not really dealing with the initial conditions versus the final conditions. Instead, we're dealing with oxygen versus nitrogen monoxide. And no, we're dealing with two different substances in this problem. So with this problem, what we can do is we can just go ahead and plug in our numbers like normal. We have our oxygen. We're trying to figure out V2, by the way, in units of milliliters. I'm sorry, V1. We're trying to figure out V1 with the units of milliliters. We have a temperature. Good thing it's already in Kelvin, no adding or subtracting involved. And we have a pressure of 755 mmHg. These are all some descriptions about oxygen. In terms of nitrogen monoxide, I see 180 milliliters of nitrogen monoxide. I see that it's measured at 318 K, and we have a pressure of 720 mmHg. Now, there's one piece of information that's not so obvious, and it is built into the equation, the balanced equation. If you use the coefficients in front of the substances, like in front of oxygen, we have 1 mole in front of oxygen, and we have 2 moles in front of nitrogen monoxide. These numbers come straight from the coefficients of this balanced equation, so make sure you know that the number of moles can be found from a balanced equation. Once we have all our numbers in place, we can go ahead and plug it into our formula. The formula we're using is the combined gas law, and we're actually using every single piece of it. We're just going to go ahead and take all of our numbers now and place them as they represent P1, V1, N1, T1, P2, V2, N2, and T2. Now, if you want, you can go ahead and hit pause right now and solve for V1 using algebra, and you might want to just test out your algebra skills here to see if you can get the right answer or not. And if not, then I'll show you an easier way using some cross multiplication. If you are ready to move on and you did the algebra, let me just go ahead and let you know that the answer we determined was 79.1 milliliters. And if you didn't get that, let's go ahead and talk about an easy way you can get that. I recommend that you use cross multiplication because with this proportion, we can easily get an answer without having to do too many keystrokes, without having to stop and write things down. We can just write everything all at once. So using cross multiplication, you can recognize there's a cross here and there's a cross here. We always start off with the cross that does not have the unknown variable, so these numbers in this cross are what we're going to multiply first in our calculator. We're going to do 1 times 293 times 720 times 180. You don't even have to hit enter. We can just go ahead and finish off the problem by dividing by all the other numbers in the cross. So continuing on with that same thing, divided by 318, divided by 2, divided by 755. Now you can hit enter and you'll get this number, and I've rounded this value to 3 sig figs Doesn't even look like I should have 3 sig figs. Maybe this should just be 2 sig figs, 79. And we don't include sig figs with a number of moles because that's just a definite number. It's not a measured value. So 79 milliliters is what we should end up with the 2 sig figs if I had corrected it based off of these two values that only have 2 sig figs in them. And that's it.